Hello everyone. So continuation of our last video, we are starting our series on electrostatics and this will be the first lecture on electrostatics. Also, I have gone through all your comments and suggestions and surely I'm thankful for you to all of you for giving me suggestions and feedback for my first video and I'll surely take all of them into account in our roadmap. Not obviously from today itself, but in our roadmap, surely we will consider all of them. Yeah, I have seen comments about starting class 11th and thing. We'll be surely doing that very soon. Okay, so starting with our topic, which is electric charges and field, which falls under the branch of physics called electrostatics. If you want to make notes, it will be useful for you during times where you need some quick recap of things, obviously. So coming to electric charge and field. So again, I'll start today also with charge. So what exactly is charge? As explained, charge is nothing but fundamental property of matter because of which there exists electrostatic or electric force between two similar objects. The force may be attractive and repulsive. Okay. So this topic deals with the behavior of charge. The charge at rest means the charge which is at rest and there is no velocity or speed associated with charge. We'll be talking about those type of charges. So talking about, let's get a bit behind into history and think about how charges were discovered. Like we know that there are positive charges and there are negative charges, but we should also know that how those charges were discovered. So uh, let's talk about a brief experiment. So let's say we have a glass rod and we have a silk cloth. Okay. So if this silk cloth is rubbed against this glass rod, and let's say we have one more glass rod 2, and then one more silk, and then again this glass rod is rubbed against this silk. So after doing this, when these two glass rod were brought close to each other, the inventors or the scientists they found that these two are actually repelling to each other. But and similarly when these two silk clothes are brought close to each other, they were also seem to be repelling each other. Close to that, when glass rod and silk were brought closer to each other, they seem to be attracting each other. This basically tells me that there are two nature of forces here. One can be attractive and other can be repulsive. Now let me change this glass rod and silk with a, let's say we have a plastic rod and there is a piece of fur, and these two are also rubbed against each other. So what was observed that this glass rod and this plastic rod, they seem to be attracting each other now, and case is opposite with again glass rod and fur, which is seem to be repelling each other. So this basically tells me that there is a property which is common between two different objects, but which is uncommon to the others. So basically, glass rod has a specific property, a plastic rod has a specific property, and they are aligned to each other, hence they are attracting. But similar to that, when there was another glass rod which was rubbed against silk and then brought into contact with this glass rod, they seem to be repelling each other. So during ancient times, Benjamin Franklin classified these as two different nature of charges. So one is positive charge and another is negative charge, which we all know. So let's say let's say when glass rod is rubbed with silk, it develops one type of charge, and silk develops some another type of charge. And similar, plastic rod is rubbed with fur, it develops one kind of charge, and fur develops another kind of charge. So yeah, so after that, there was is a convention which we know that like charges repel each other and unlike charges attract each other. So which basically means the charge which was developed on this glass rod was different from the charge which was developed on this plastic rod, right? And the charge developed by glass rod is what we call as positive charge. Positive charge. And the charge developed on plastic rod is called as negative charge, which is basically negative charge. So yeah, okay, I think this is clear. uh, so in the last experiment we understood that when two objects are rubbed against each other, they develop a different kind of charges. One type of charge is positive charge and other type of charge is called negative charge. So the question arises now that how do we say whether an object, whether a body is charged or not? Like हम अपने दिनचर्या में बहुत सारे वस्तुओं के समीप आते हैं, हम कैसे कहें कि कौन सा ऑब्जेक्ट उसमें से चार्ज है कि नहीं है? हम कैसे कहें कि कौन सा उसमें से ऑब्जेक्ट है जो न्यूट्रल है? तो उसको पता करने के लिए, टू एनालाइज दैट, वी हैव एन इंस्ट्रूमेंट which basically tells me whether an object is charged or not. So that instrument is called as electroscope. Electroscope. So what exactly is electroscope? So electroscope is a charge sensitive instrument. So it will respond when a body charge is brought into contact with the particular instrument, and it won't respond if an uncharged body is brought into contact. It's as simple as that. So there are two types of electroscopes which was invented. One is called as gold leaf electroscope, and another one is called as pith ball electroscope. Okay, so we'll be talking about gold leaf electroscope, okay, in detail, and we are not concerned about pith ball electroscope as of now, which is not in our scope. So gold leaf electroscope, so it basically tells me that there is an instrument which has some leaves which would be the indicator of a charge on the object, the concerned object. So how it looks like? So we have a metal disc. So this is a metal disc, might be made up of aluminum. Then we have a metal rod, let's say brass. This is brass rod, and then we have two thin metal strips connected to it. So to house this, we can house it in a some kind of a container or something. Which can have a cork here on, something like that. So this is how a prototype of a gold leaf electroscope looks like. So these metal strips or gold leaves, these are called gold leaves. So these are the charge sensitive leaves So how it detects any charges? Let's say we have a charge body. This is a charge body, and this body is having positive charge. So when this body is brought in contact with this particular metal disc, so this charge is transmitted to this metal, and this charge is distributed in both these leaves. So since we know that like charges repel each other, these two leaves will start converging, sorry, diverging away from each other. So these two leaves, if we acquire charge, we will see them diverging a bit away from each other. So the amount of this particular divergence is proportional to the amount of charge. If charge magnitude is very high, the divergence will be very high. If charge magnitude is low, then the divergence will be less. So that is directly proportional. That's how it indicates the presence of charge and also the quantity of charge. And so now we have brought this object, this charged body in contact with the electroscope, and we see the divergence coming up. Now let's say there is someone is standing here, and he goes and touch this particular object. So what will happen? Since our body is conductor, this earth will supply this electrons and neutralize this particular charge, and we will see that these leaves have come to its mean position and there is no divergence anymore, right? So yeah, this is about gold leaf electroscope and how it detects charge. Broadly speaking, it is also used to quantize amount of charge by showing the angle of divergence it has. Okay, so now we studied about how can we detect presence of charge on a particular object or a body. Now we will talk on how can we charge a particular object. Like just now we saw that we charge that electroscope. So something similar, there are a lot of methods to charge a particular body. So methods to charge. So first method is called friction, or simply we can say it is by rubbing. Okay, so we just saw in the beginning of this lecture that when a glass rod is rubbed against a piece of silk, they developed an equal and opposite charge. Let me not say equal, we will talk about that, but they develop opposite nature of charges. So what happens in rubbing? Charge is what? Charge is basically the electron. We know that in an atom, protons and electrons and neutrons, these are the subatomic particles in an atom. Protons and neutrons lies inside the nucleus, and that is tightly bound. Electrons revolve around the nucleus, and they are the ones who which can charge any particular atom on or body. So electrons are the ones responsible for creating charge. So now let's say this is one object, this is another object. So when two objects are rubbed against each other, the object which has tendency to lose electron, it will lose electron. This glass rod will lose electron, and this electron will be shifted to silk. So what happens? Now glass rod has more number of protons than electrons. It will develop a positive nature of charge. We know that electron is negatively charged. And silk will take that electron and it will develop a negative charge. So now using rubbing or friction, we have developed the charge here. Okay. So second method of charge is by conduction. So what exactly is conduction? So the name itself suggests that there is a conduction between one object to another. So in this particular method, let's say we have an uncharged body. Let's say this is a uncharged body, and now we have a charged body. Let's say this is negatively charged body. So what we will do is we will bring this charged body in contact with this uncharged body. So there is a direct contact here. So this negatively charged body comes into contact with this uncharged body, and now what will happen when this negatively charged body comes into contact with this uncharged body? What will happen is it will share its charge to the uncharged body till these two acquire a common potential. So let's not get into potential. Let's think like that when we have a let's say when we have a container full of water, and then we have a container which is having minimum amount of water, and we connect them with a pipe. So this water will flow from the high side to the low side. Similar to that, here also we see that charges which are surrounded on the surface of this particular conductor, in this case we are calling it as a conductor, so they will start propagating to this surface as well, till they both become electrically potentially constant. So let's say this body are having same size, and this was having some charge called x. So now after coming into contact, this will become x by 2, and this will also become x by 2, and then the flow of charge will stop. So this is what is called the conduction way of charging. Okay, coming to the third method. Third is by induction. So we see that in conduction we had to bring a charged body in contact with an uncharged body, and then the charge is created. But in this particular method, this is a contactless method, that here we won't be bringing two bodies into contact, but without bringing them into contact we will developing a charge in them. So let's say that uh, let's say this is an uncharged body, and now we bring close here a negatively charged body. A significant amount of negatively charged body is being closed here. So we know that unlike charges attract each other and like charges repel each other. So this negatively charged body will repel all the negatively charged electrons and try to push it away from each other, as away as possible, which in turn which bring the positive charged species to the leftmost part, since negative charge will attract the positive and repel the negative. Now you see that the center of negative charge is shifted to the rightmost side, and center of positive charge is shifted to the leftmost side. So what we have done is, without even bringing these two objects into contact, we have induced a charge in them, and this is the method of induction. So now let's say that I need to keep one charge, and I need to let go some another kind of charge. What I can do is I can connect this particular to ground. So ground, you know that it will share charge with this body, and the negative charge electrons will flow from here. So this body will become a positively charged body now. So now we see that we have developed a charge in a body without even bringing two bodies into contact, and this method is called charging by induction. So again, going back to that experiment where we saw that when glass rod and silk cloth were rubbed against each other, they actually became charged, and they started attracting the pieces of paper or things we uh, bring in close to them, which I just explained, which is actually by induction. But if you try this thing with some metal, let's say some steel or something, some steel spoon, it won't work like that. You won't see that it attracts pieces of paper or things. So what exactly is different between these two bodies? Okay, so in terms of their charge transmitting capabilities or how they carry across charge between themselves, these type of bodies are classified into two types. You all already know, based on the electrical conduction, one is conductor and another is insulators. Okay, so materials are classified into two types based on charge conductivity or electrical conductivity. One is conductors and another is insulator. The name is itself suggests the conductor will allow a smooth passage through itself. It will allow charges to flow across it. So when a charge is given to a conductor, it won't remain at a point. Let's say this is a conductor and I charge it at a point, it won't remain at a point. It will instantly disperse across its surface since it is a conductor. But in case of insulator, insulator is something which will not allow the flow of charge or current across it. So when a charge is given to insulator, it will be dispersed at one point only, and that's why you see that those kind of attraction or repulsion behavior, which I just explained. So these are two types of uh, classification of material based on the conductivity. So you know that human body is also a conductor. You also know the metals, all different types of metals, they are conductors. Why? Because metals have a tendency to lose electron, they have free electrons. So they'll allow current to flow through it, they'll allow charge to flow through it. So they are conductors. But something like glass or plastic, they are non-metals, right? So let's discuss a problem over here, which I will not give you a solution, but I'll expect you to get a solution out of it, and maybe you can post in the comments. So problem. So let's say there are three objects. Masses of objects are ma. Names are a, b, and c. Masses are ma, mb, and mc. So now we say that initially ma equal to mb equal to mc equal to m. Let's say there's a m kg maybe. So this is the mass. Or let's ignore the unit as of now, be it any unit. Okay, so now what happens is, what I did is I brought these three bodies in contact with each other, and now what happened is this a gets some positive charges around it, this b is neutral still, this c gets some negative charge. So now we have mass of m, a as ma, again b as mb, and c as mc. So now can we say that this equality still holds? Now I want to know what is the logical relation between ma, mb, and mc. So this is the question: what is the logical relation between ma, mb, and mc? So you need to analyze the question and give me the answer. Okay, so yeah, moving to the next topic, which is properties of charge. First is additivity. So additivity, as the name itself suggests, the net charge on a body or for a system is the algebraic sum of all the individual charges present. So let's say there is a space where we have different charges. Let's say plus 7. I'm not talking about the unit of charges now, but yeah, just to make you understand, plus 5, minus 3, plus 4. So net charge on this body will be simply plus 7 plus 5 minus 3 plus 4. So it is 13 plus 13. So this is same as talking about like if there are four masses connected, the net mass will be the addition of that. Only difference is in case of charge we have different polarities, but mass we have no polarity. So yeah, so the addition of charge is also similar. So this is the additivity property. So talking about second property, which is conservation of charge. So everywhere you see conservation, it's all the same rule. Charge can neither be created or nor be destroyed. So whenever we are creating a charge on object, we are not bringing something new from anywhere. We are getting things from the object which is existing. We are not creating charges and we cannot create charge. So like I said, let's say there is a body A and body B and they are rubbed against each other, and this actually develops QA charge and this actually develops QB charge. So net charge is still constant. So initially both were uncharged, so initial charge was 0. So now also QA plus QB will be 0 only. It might be the case that it develops plus 5 and it develops minus 5 and net sum is 0, but net sum will always be 0 because the number of electrons which A loses will be equal to the number of electrons which B gains. So the positive charge which A develops will be equal to the negative charge which B develops. Hence the amount of charge is conserved. So the conservation of charge will say that the net sum of charge for any isolated system is always constant. Isolated system means this system is isolated from everything and there is no external intervention, maybe earth or any other third party, a third charge body, something like that. And the last property of charge is quantization. So this was suggested by Millikan, a scientist named Millikan, in something I think 1912. So Millikan said that charge is always quantized. So let's understand what exactly is meaning of quantization. So let's say a body A gains charge by losing electron. So it can either lose 1 electron, it can lose 2 electron, it can lose 3 electron, it can lose 4 electron, it can lose 5 electron, and so on. So all these charges which it will develop, be it positive or negative, or be it gaining or losing electron, but it will always be integral multiple of the charge of electron, right? So any charge on any particular object will be the integral multiple of charge of electron. This is what we call as the quantization of charge, right? So if I write in terms of expression, I'll say Q, which is for charge, is equal to Ne. E meaning the charge on electron, charge of electron. N is any integer, and Q is net charge on any object, right? So now talking about the unit of charge. The unit of charge is coulomb. Coulomb, represented by C, but it is coulomb, right? So this is quantization of charge, that we can say that charge on any species is the integral multiple of charge of electron. And yeah, for those who don't know, the charge on electron is negative, which is minus 1.6 into 10 to the power minus 19 coulomb, right? So let's try to define what is coulomb, but this is not the scope of this chapter, but we will define what is coulomb. So I said that coulomb is the amount of is the unit of charge. So let's define a unity coulomb. What is 1 coulomb? So 1 coulomb is defined as amount of charge which flows through a conductor or a material when 1 ampere current flows through it for 1 second. So don't worry about ampere and things. We'll talk about this in third chapter, but just for an understanding, 1 coulomb is the amount of charge which flows through the body when 1 ampere current flows through it for 1 second. So there is one more exercise here. Now we need to find that how many number of electrons are present in 1 coulomb charge. So this would be an exercise for you, but just to give a background, so I just said that charge on one electron is 1.6 into 10 to the power minus 19 coulomb. Now can you use unitary method and tell me in 1 coulomb charge how many electrons will be present, right? So we'll stop here for today. In next topic or in next lectures we'll talk more on the uh, what is the force of repulsion and attraction between two charges, and how does we calculate that, what are the fields, and more things in this chapter. Thanks.